And today we will discuss two interesting problems in Matlab: how to build a graphic user interface and how to be prepared for our final project. At the end of our meeting, we will discuss also this. Now let us begin, and I also start our screen. Okay. About 4 years ago, Matlab started to build new instruments for making graphic user interface. The first one is... Sorry, Ruben, you will...
על הסדנה הזאת, לא על הסדנה, על הסייבר. על המכונית מעופפת.
Ruben, maybe you will mute your microphone.
לא, זה סגרנו, 75, 75. שלחת לי משהו שאני אוכל להעביר איזה חשבון וכולי? כן. לא יכול להעביר, טכניוני אני חושב. אין לי.
מיכאל?
צריך לדבר. בואי, אני לא יכול לדבר אבל עכשיו.
The recorded lessons by email?
Already in your chat, you already can see these links to these recorded lessons. Okay?
In the chat?
On the chat. Can you open your chat and see?
Yeah, sure.
Okay, okay, good.
I don't see anything, though.
Let me check. On the chat. I can see in
nice. Now I can see. Yeah.
Okay.
Okay. Thank you.
Yeah, you're welcome. Now let us continue. We'll start at about that. The Matlab already about 4 or 5 years already use this an instrument for live editor and for application designer. And what is this new instrument in Matlab? This is they call it new live script. Script. Already you know that Matlab has a plain Matlab script. It's a M file, Matlab file that can include the multiple lines, sequential lines of Matlab commands and functions called. And you will also can run a script but typing its name in the command window, and the same way you can write and run function in the Matlab. And instead of writing such code and commands in plain text, we can also use a formatting options in live script to enhance your code. Let us open an empty live screen. In Matlab main window, you have this button, the second button from the left, it's new live script. When we press this button, we will have a new live editor for working in live script. It has 3 tabs. The first tab, it's live editor itself, and it just the standard operation with files, open new files, open files existed, save file, find files, and also how to control our work in editor, how to run it, what is the section inside the live script, and so on. There is the second tab. about inserting different kind of work. It could be control instrument to insert, and we can see the example of this control. It could be numeric slider, draw box. I can open all this panel here if we can just move it, and we can choose, for example, this kind of slider. It could be inserted in our editor. It also, we can insert some section breaks. We can insert text, we can insert tables, images inside our script, hyperlinks from the web and from the local source. We can insert equation. Just let me show you. We can just put integral here or something. As before this live script, it was impossible to build in the script something equations. And in general, this live script is very convenient, and it save code, results, and formatted text, and it all combined in a single document. And also, this live script can show alongside the code itself and also the results of the execution of the code. And live script is different. It save the files ML format. It's a zip format of files, and also it's a new kind of saving, because now we can use in the name of the file, we can use different, we can use plus, minus, different signs, we can empty space, and it's also sometimes very convenient. And live script is MLX format, is the format of Matlab script. And what is also interesting, now in this live script, we also can make zooming of the font, number of fonts, number of viewing. Let me show you. If we press Ctrl and just play with our mouse roller, we can just to see how we can change the zoom of the screen. It's also sometimes convenient to show on the screen the results.
I have a question.
Yeah.
So can it solve the integral, or is it just a picture?
It's just a picture. Just a picture. If you just would like to explain something, you can just insert pictures. You insert the equation, mathematical equation. You also can format some text. For example, I can some letters, and you can just format it, make it build, maybe just underscore on different kind. We can just to make it more. You see, it's a different kind of formatting text. It's also sometimes you need to do it, and Matlab planner script cannot do it. Okay. We will start just to illustrate the possibilities of live script, just in some examples. But before, let me show, there is a standard Matlab function pix. This function is built inside the Matlab, and it is a function of two variables, and it obtains by translating and scaling Gaussian distribution. And we will use it just to see what can be done in live screen. Okay, first we will insert the control, the numeric slider, and we would choose the slider. For example, label could be something else. It doesn't important. Now we choose the minimum values of this slider. It could be, for example, 0, and maximum could be 1, and the step could be 1/100th, and that's all. What is interesting that each inserted control, if we put from the left a variable name, it will be the name of this instrument. For example, if I say that A is equal to our instrument, now A is variable. We can just in live editor, we can run, And we can say the result because our slider is in the first position from the left is 0 and A is equal to 0, okay? Now let's put the second line in this editor. It could be our peak function, and we will do it this way. We plot a surface in Matlab, and we will plot it as our amplitude that is now is a variable that we can change its value by a slider, and we multiply this our constant factor by the function, and we can limit the z function to make it more beautiful from 0 to 10. And that's all. Let's see what can be done now. Now, when I can run this live script by pressing the green button, run. Here our surface, and from the 0, just the 0. If we can just play with the button, you can see we choose scaling, different scaling of this plot, and we can make these peaks in full stage visible in the mesh plot, in the surface plot, sorry. I believe that everybody can repeat this operation and just build. What also can be done in live script, we can close the code and only show the result here. And also it works also, but we have no, okay. This way it also can be run. We can return our script from the left and see how it built and how to work with the script itself. And what else can be said about it's an interactive editor, and for lessons and for maybe for explain something in Matlab now, this instrument is very useful and I can recommend it. It's just a new instrument. It was started from the Matlab version, if I'm not mistaken, 2016B, and now can be used in any other and any future Matlab editions. Okay, let's do something interesting.
Could you please explain what's peaks again?
Yeah, we can do it this way. Let me show you the Matlab. When we can just in Matlab window, if you write peaks command, you will get this help from the peaks. Peaks a sample function of two variables. Peaks a function of two variables. It's inside the Matlab. We can just if without variables from the left side, if I write here in the command window peaks, we just get the picture in the figure. It's just where you can see how it looks in Matlab figures. You can just see from different size. It's function of two variables, the variables x and variable y, and different kind of representation using mesh command, using surface command. It's a typical 3D plot that can be used for explanation, for demonstration in Matlab. Okay?
Thank you.
Okay. Now let's go back to our live editor, and we will start a new editor. Please, you already get it, and we will start. We can open maybe this way. This is I will close, and we'll start from the beginning. New live script. And here we will write the first our example. Its name is R3_1. And when we run it, we should get results in Matlab. Let me check if we have this example. Yeah, it works. Okay. we will plot, not only plot, we will make a prognosis of population in the country. Let's take an example of United States of America, and we will use the statistic data of the population in the United States maybe many years ago, and we will try to make a prognosis, a forecast, extrapolation of this number of people in the United States in 30 years. How we can do it? First, I already inserted this data from the 10 years ago, and what we need now, we can make a new section. Let me show you how you can do it. There is a button section, and section you ask for section break, and here we will start our script, live script. The first line is years. Years it's equal, from 1900s till each 10 years increment till 2020. Okay, 2020, it's our year. And for this data, we already have inside this script, we already have a number of people. The variables is population, pop. Now we can check if it works. Let me check the length of our years. And we will run it. Years, sorry, years. Okay, we have 13 years, and we should also have the number of people in the United States. It should be also 13. Let's check. Yes, also 13. It's good. We can continue. Now, let's plot, or make it do it another section. Again, I will ask a new section break, and we can plot this number from the years till the population, and we will choose blue color and circle, small circle, and we will maybe limit the axis from the 100 years ago till our time, and also from 0 to, okay, let's run it. Okay. Here we can see how these years the population in the United States was growing from the 1900s till our time. What can be done now? We can just make a regression analysis just to make a polyfitting, find a polynomial which explain these lines. We can use different different degree of polynomials. How to do it? Let's do it. The coefficient for linear, for first order, it is a function polyfit, polynomial fitting. Here Matlab helps us. And but before, we better to make reducing the years, not starting from 1900s, let's starting from 0. We can do it this way. We can just make x is equal to years minus the first number of years, and all this we will divide by, for example, 50. Now it's better to make a fitting x. It's our argument, and our function is a population. And the first degree, it's just 1. It will be the first degree of polynomial. And the second one will be practically the same, but copy. And the second will be the second. Also, we can do the third. Then at the end, we will compare and we will understand which is better. Okay, now we have a coefficient of our polyfitting of this dependency from the years and the population. And let's plot together with our plot. Let's make again, we will go to a new section.
Why do you divide years minus 1900 by 50? Well, what does the 50 mean?
Just norming, just kind of rationing, just it could be any other number, just to start from 0. And I don't need to work with the numbers from, it could be any number starting from 0 to any number. Nothing, it could be any number. There is no something special in this number. Now let's make a valuation of this theoretical fitting. We will use a function polyvaluation, polynomial valuation. Let's make a prediction of the first level of fitting. Prediction 1 will be polyfit. Oh, sorry, polyvaluation, polyval. Again, now we have this first coefficient that we already know. The first one, it's an argument, and the x, it's our years starting from the 0. And this way we can make for different prediction 2 and coefficient 2, and also prediction number 3 and coefficient 3. Okay, and we will try to now to plot our graph. Again, let's make a new section, and then let us plot it. Let's plot, and let's hold on our circles first to see the difference from the real numbers and the prediction. Hold on, sorry, hold on. Plot our years. We can now do years and the prediction.
Michael,
yeah,
like your whole on needs like a space.
Right, thank you. And now we can make all prediction together. Prediction 1, prediction 2, prediction 3. We need them to be vectors in column, not this row, not the string. That is, we should use a transpose. And also, let's build here legend to know the difference where we are. The first was, it should be data. It's our circle. The next, it will be linear. The next one will be quadratic. In the quotes, sorry. And the last will be cubic. Let's see what can be seen now. In section also, we can run this section from the beginning, run and advance. Runs this section and go other, run this section and go other. And let's go now for our section, for the last one. Okay, let me show. You see the linear, it's our linear prediction, and the quadratic and cubic, they are more precise. If you can see that our circles of the real statistic data, they go very close to the high level of the polynomial fitting. It means that the linear is not so good in this case, and the high-level polynomial it's better. Now the main, how to say, the main interest of our work is just try to know what will be if this function is right and this tendency of population increasing in the United States is the same. We can try to know what will be in 30 years. How to do it? Let's go again a new section, and we will.
Can I ask a question, please?
Yeah, please.
Before you continue. So what you did is you chose polynomials of different degrees, and you checked which one fits the data better, right?
Right, right. You're right.
Okay, okay. Thank you.
Now let's make a forecasting. Let's make a years 14, because we have only 13 till now. And this we will make a year in 30 years. It will be 2050. Okay. For this year, we need to calculate a new x, our new x, reducing x. It will be the same as we did. We just need a years 14. Minus the first one, and all this we will divide, by 50, the same number. Okay, now we have x, and we have, let us.
Michael,
Yeah.
shouldn't it be like x number 14?
Oh,
like
yes.
Okay.
It should be only for this. And also we need now to do this from the very beginning. We should make this execution and this right. And now we can plot again. We can plot using our plot.
I think the year is 2030. Why it's 2050?
Doesn't matter. You can check. You can use any number.
Okay.
It doesn't matter. We can let's see what we will get, and plot this now. All this, but we need to calculate this prediction again. Let me put this again, prediction after years, and try to plot. Let us try to write from the very beginning. Okay, let's see what we get. This is our first. No. We maybe can do it from this way. Maybe just, again, we can just calculate this way from the beginning. Okay, now we will do it in live script. Don't understand why we cannot see. I know why, because I just make a limitation. Let's just remove it. No, it's only 3. Where is my fault? Let me check. Size, length, years. It's okay. It's in you. It should be. But okay, now we can just see that plotting all these graphs together, we can see the population in this country in 30 years more, and it will be no much difference from the millions. It will go about 400 million people in the United States in the years 2050. Okay.
Why did you press to get this graph?
You know, I press F9, but I don't understand why we cannot see it. Let me clear, maybe clear section here. Let's just see why it's clear output. Maybe this is my fault. It should work also here, but okay, we should clear it. Now, the first is just the statistical data in live screen. We should just press run, and we can. The first one, circles, is the real data. Okay. The second one, it's our interpolation. We can see what the theory of regression of the fitting, polyfitting can make in this data. And we make now we can make a forecasting what can be done in this year, what the size of population will be in the country. Okay.
Well, can I maybe explain like the different functions we used? What each, so like the polyfit creates interpolate, like a polynomial interpolation, right?
Right.
Polyval creates a symbolic or a mat. Is it like it creates a Matlab function of the polynomial?
No, it's not symbolic. Polyvaluation is just take this coefficient, these numbers of the polynomial, and using our argument. Our argument is the same x. It's our argument, and just using the argument in this polynomial, we just calculate the output from the polynomial. It's our prediction pred from the different levels of polynomial.
So, what kind of object is the output of the polyval? Is it like a Matlab function?
Yeah, it's just a regular function. Let me show you in the Matlab window.
Oh, okay, I see. I looked it up, yeah.
You see, this just return the value of polynomial of x. If your x, it's just your argument, the polyvaluation just return the same number of points, just using the polynomial substitution. Okay?
Yes. Thank you.
Okay.
It's very useful. I did polynomial interpolation maybe a million times during my my time here, but I've never used something that makes it so simple.
Yeah, good, because Matlab is very powerful just for these things that I tried to find some example that could be maybe useful for anybody. In general, this extrapolate forecasting just is a method of prediction, which it's assumed that these patterns of our number of people existed in the past, and we will continue the same function, the same dependency in the future. And this pattern, if they are regular and can be measured, we can know what will be in the future. It's kind of, how to say, indicator of our future. And okay, let's stop about this population and American people, and then we'll go to another example. Another example which we will use, it's our mass system. We already have it. Let me close this example. We don't need to Okay, we also clean the Matlab window. And the second example, we already prepared it. You already have it, R3_2. I believe if we, or we can just open it as a let's open from the button, open, and these are two. Here it is. Here it is. Please, you can also open it. R3_2. It's our example of solving vibration of 2 degree of freedom system, of 2 mass system. I found this example. It looks very also useful for in the Technion at least. Okay, what we have here, we have 2 masses of mechanical system. Each mass has a spring and a damping between them. And also we have different forces. The first forces only act to and press the first mass, and the second force just excitate the second mass. And we here, by using the Newton law, we can write the equation of motion. We did it already in our first lesson using Matlab. Already we also did it in our second meeting by using Simulink. I believe that you already, how to say, should know is that just this system of 2 masses and 2 springs, a damper between them, and 2 forces, it should be familiar for you. And also we should remember from our first and the second lecture, the state space equation, the form of equation that can be developed from to solve this kind of problem and to find the motion of this system. And this kind of presentation, here I just remind you, this kind of presentation of this state space equation, it uses 4 matrices. First, it uses the first order equation of motion. It means that each second order equation we should write in as a 2 first order equation. It means for the system of 2 second order equations, we will get 4 equation, a system with 4 equation, first order equation. And we can use a state space to insert it in the Matlab. Our matrices, let me remind you, the first A matrix is our state matrix. It's explain the system itself, its structure, how it connected masses and springs and damping. B is the input matrix. B is our forces, what kind of input we insert in our system. C is our output matrix, it's our motion, the result of our simulation. And D, always in our mechanical problems, it's always 0. But again, we should know the numbers of rows and columns in our representation. Here it should be 4 numbers. It means that 2 rows and 2 columns. Now, also we already did it in our previous lectures, how to write this system in coefficient, and now we can insert it in Matlab. I already show how it can be done, but we can do it from the very beginning, or just you can copy these lines in Matlab. We should define the M1, M2, K1 and K2, just springs, all masses, and the damping between them, okay? And now we can write this matrix A. You can see the first line in the matrix is 0, 0, 1, 0. The same we can write here, 0, 0, 1, 0. Dot seek, it means that this is the end of the first row. We will go to the second row. The second row also is 0, 0, 0, 1. It's our second row. And the next row, it will be this minus K1 divided by M1, 0 minus B divided by M1. And the last row in the matrix will be it gets the same way. You already have this number. The B is our matrix input. It's our,
Michael?
Yeah.
I already have the file, I already have the picture.
Sorry?
File that I have already have the picture, you don't have the code.
Okay. Okay, can you repeat just, I will wait that we will repeat, that you will repeat. Let me know what, if you have, let me just delete it and we will do it from the very beginning, I believe.
No, I mean, like, can you send it through the chat? Because I don't have it in the file you send me.
Okay, let's do it. And the chat, where is our chat? Okay, and also we will do it with the T. To make a solution for our system, we need, let me clear output. The time of our solution should be defined. It means that the minimum of T, the increment, the step of our time, and the maximum T. Would you like also get it from the chat, or you can repeat it from the screen?
You can send it to the chat.
Okay. Now.
Okay, thank you.
You know what? I believe we will do it ourselves. It takes some time, but it's not so important. Okay, when we have this time, and we will need to find or to make the F. Oh, the initial condition, I don't remember if we do it, but let's do it again. The initial condition of our X, it should be a matrix, a vector, it should be 0, and should be 0 and 0. Arbor, 4 numbers, okay. And F, we should define the F of our force. The force will be, it could be a 0 force without force, but the solution should be interesting because we have not 0 initial condition. Let's do this force it kind of 0. But again, it should be the matrix length. Our matrix, it's T and 2 numbers. Okay. And it could be maybe enough to solve the solution. X1 we have. What else time we have already? Okay. We did it twice. Now we should make a solution. Why it's our solution? It's our output from the system. We know how to make it simulation. We also did it in our previous lection. It's simulation. We need in simulation our matrix A, B, C, D, our force, okay, and our time, and our initial condition. I believe that we have everything. Let us start. We can just try to run our script. Let's see if something is not good. No, because it should be T. Okay, okay, no errors, it's good. We get this solution. Why? It's our output from the system, and its output, it includes 2 vectors. Now we can plot this solution. Let's do it. Plot, and it could be as a function of time. Why? Let's do it, for example, both of them. The first one is our displacement, and the second one, and displacement we will plot in black color, and the next one, t, y, the second vector. And here we will use, for example, the red color and dash line. Let's see if it works. Okay. Here we get the solution of our system. Why we know why we have two lines, two solutions? Because we plot the black, it's our displacement, it's our motion, or our position, and red color, it's our velocity, our first derivative. To know the difference, we can just put here legend. Let's do it. Legend. The first one, it's position, and the second should be. Oh no, why it's not? It's just the position of one, mass one. Mass one, and the second. Two. Okay, let's see if it. Okay. Here are our results of our. And the last step of our example, we will do it in another kind of excitation. From this example, we use a zero excitation and not zero initial position. Now let's try to use different kinds of excitation. Let's use a sine wave. We can do it this way. We just choose a frequency of sine. It could be omega. It could be any number. Let's do it. 5, and also we can make a value of force for the first mass, acting at the first mass. It could be 0 as a function of our length. It should be our time exactly as length of time, and this is for only first one. It should be 1. And now we can do it for the second. It also, but now it should be a sine wave. It could be a kind of amplitude and the sine wave. And here we have our frequency of motion. It could be omega, and multiplied by our t. Okay. And the force in this state space equation is a matrix. We should just write it correct way. It should be as force number 1. Sorry, it's a capitals. But here sign, we should have a column, not vector. This is why with the second one, we should make a transpose of this vector from column, from row to volume. And again, we need an initial condition. It also could be 0. Now we don't need any numbers here. It should be 4 zeros. And we should just make a solution of this system. Again, the solution is new solution. Y it's equal to simulation A, B, C, D, and we should divide them with the psic. And after that, it should be the force, and it should be the time and the initial condition. And let's try if it works. Everything is okay, no errors. And the last thing, let's plot it. We already have this plot. Let's repeat me. Let's take this plotting and make a new section, just to devise section break. And let me run this. And no, this should be our new function. Okay. The first our example was for the zero force and initial, not zero initial condition. It's kind of free vibration. If you know the theory of vibration, it's a free regime, and the system goes to this steady state space. In our case, it's just zero steady state. And this kind of forced excitation, we can see that having a force as a sine wave, we have a solution without any interruption. It will continue till we have this force. What good for this live editor? Now we can save these examples, save as we can choose a name, for example, another name as example number 1. And we can close our live editor, and we just can open from the Matlab. We can open our example, and we will get it already. We just need to run it, and we will get from the right side, we have the solution. We also can just hide our code and only run and get the solution at the end. This way we can explain to everybody how it works. Also, what is good for in this live editor, this live script, then we can save not only as a live script, we can save different kinds. Please look and save. We can save as a PDF file and have a good document. We have export to Word and have all the picture good quality and the text already in the Word. We can export to HTML and be ready for browsing in internet. Just to put this result, this example in the internet, it will be already ready for the internet. Also export for LaTeX if somebody knows LaTeX, and we can do it. Okay, now let me show some example that you get it ready. I will close this and let's open example that have a name R33, if I'm not mistaken. Let me check. Yeah, it's a pity, just wasted time. Just please, yeah.
I will talk on behalf of the audience. You know, one of the students told me that you have to give him time to ask questions and think. So if you don't mind, please let them ask question about the former example. If they don't have it, don't have it. But you know, they think it's too fast for them to understand the material.
Okay. Let's.
Sorry, but I am the voice of the people.
We have heard a voice from the people, from the sky. A voice from the sky. Somebody has a question, please. And I use this time to drink a little bit. No, it means.
Yes, yeah. I have a question. Please. So, is the live script the better version of Matlab normal code, or it's just for a specific purpose only?
It's no, it's just a good purpose to write any script that you have. You can just put in live script, and it's very good to explain to somebody else. If you are not only a teacher, but you need to explain to your friend, to your colleague, how it works, and get it together, everything, the script already, and the results, and the displaying, and the graphics, figures, all together in one piece. It's very useful. Just use it. It's a new instrument, only for years from now, and I believe just it's very pleasant and very useful.
Michael, can I add something, please?
Right.
From my experience, I've been working with the live script. I didn't know all the functions we use today. I usually just use it as a script, but it's really easy because when I plot things, then I can immediately see the plot, not in different windows and stuff. But there is a big limitation for the live script because when the codes get complicated, for example, if you run a code with 100,000 iterations, it tends to run really slow. So it's a lot slower than working with just the standard script file. So if it's a simple code or nothing too demanding, then it's really nice. But for a numeric like a numerical analysis and stuff like that, it's sometimes too slow.
I agree. Yeah, it's correct. You know, we can just make how to say association with, for example, we can work with the text in Word, and also we can work in PowerPoint to make kind of presentation. I believe that this live script, it's more for presentation, more for explanation, more for make it beautiful way to explain your thoughts, your equation, but not to work with a difficult and complicated system. Required a lot of solutions, a lot of executions. Right, I agree. But it's nice and new and better to know this way of presentation of graphic user interface. Okay.
Okay, thank you.
Yeah. Now we will do another. We will try to play with another example of graphic user interface, which also it's new one. If you worked with Matlab 4 years ago, it was another. I can show you the first one, which was many years before. We call it guide. We can help guide. It was a kind of graphic user interface design in Matlab and was very popular many years ago. But if we check in documentation of the guide, they already wrote the guide environment will be removed in future release. Please don't use it. This is why today we will try to be familiar with the application designer. Okay. And application designer, it's a new instrument. And to start with this application designer, we should write its name in the command window. It's just app designer. Oops. Designer. And this will open a new kind of window with some examples of this application. We just to start to work with this, we just choose the blank application in this designer. In general, this application designer, it's recommended for now application in Matlab. And it is strongly recommended to use this application designer and let us to create, how to say, professional application without having to be a professional software developer. It looks like a Simulink, some kind of Simulink. We can just drop and drag visual components. From the left side, we can see this is the component library. Here you can see examples of this component in this library. There are some kind of drop-down, edit fields, images, and there also can be from the toolbox. For example, there is Aerospace toolbox in Matlab. We can choose any kind. What can be done, each instrument from the left panel of this component library, we can just drag this example in our design view and work with this. It's the first. Also, it has two buttons. The first button is the designer. It also is kind of tab which works with the files. Open, new, save, and run. And the canvas is just the main tab for working with the designer. This tab also has three panels. The first panel called component library. We can choose something from here. The design view, it's our design. We will use it to build something. And from the right side, it's component browser, and it allows us to see how it's just assign the variables and functions, how they are assigned in our application designer. And we can just start. For example, let's start from something kind of calculator. Let's try to do it. A kind of calculator is 8. I can show you, for example, let's insert the text, and just to play what I will try to do, just A plus B, and we will find the solution of this equation. Okay. Here we can also play. For example, if I don't like the value, the size of this font, I can ask here in my component browser to change this font size and make it larger, for example. Okay, now
Michael, I have a question.
Yeah.
Is this app designer, which platform do we use this on? Like, it's only used on Matlab, or we can use on web or in phone or something?
Yeah, it also allows us to save in different format of this export. It could be exported as a Matlab file, but it will be work as a stand-alone executable file. It looks like an exe file that can be run inside the Matlab, but also it could be transformed to stand-alone executable without Matlab. Also, there is a way to do it.
Okay.
But now it's just inside the Matlab. Let's do how can we do it, this calculator, kind of calculator. Okay, let's insert. We don't need it more. Let's insert the edit numeric field, and this is our A, and this is our B. Will be okay. And we need the result, show the result. Let's be, this is our result, and we show for example, the push button that will continue to work. Now, let's see, each instrument, it has two variables. In the component browser, it shows the edit field, it's our edit field label. We can change it. And here we can change and write something, for example, A. Okay, and also the second field, it's just our field, it's a value itself. The same is here. Also we have the label and the field, and the last one also we have the label and the field. And the button, it's working as a push button. We can push and make some execution, some code. To insert the code, we can press right button in the mouse and go to the callbacks of our program and choose the callbacks. Now we don't have nothing, we have nothing, and this is why just add button push function callback. Okay, already Matlab just automatically goes to the right place when we should place our command. Okay, but first we can just replace. For example, we will replace for the A button. We will replace here as a A, and the second we will replace as a B, and the the results. Sorry, we'll write here result. Okay, And now let's insert the what we need. Here we need application value from here. And its value is value. And this is our A. Our A is equal to this value, okay? Now the same we will do with the B. B as a variable is equal to B, and we will take the value. Now the calculation itself will be the result of this. Sorry, we will need more space here. The result, I will drag the result here, and the value result is equal to A plus B dot psych, and that's all. Let's check if it works, and we will need to press run. Let's see if everything is okay. We need to choose the name of the file. Let be our test2, and we will get our executable file, and we will try to press the button and to see if there is no mistake, there's no errors. And speaking the truth, it's okay, because 0 plus 0 is 0. But let me check here for 3. Here could be any a number. Let me see. It's 8. You see, it works. We can see any also negative numbers. This way, we can just make a graphic user interface for calculation of or any kind of arithmetic or logical operation in Application Designer. Okay, Professor Ruben Katz asked us to make just interruption, just make a small pause to ask if you have question here. Any question here? Okay, let's continue some examples with this designer. The next designer we will do, let's go to a new kind of screen. Here we just take a new one, application designer, a new one, black application, and just make something more beautiful. We will work with the knob and gauge. Here I already saw them. Here, for example, we have a gauge. It's our instrument that can show anything, and we have here just knob. It's our instrument that can choose any number. Speaking about the presentation, we also here we can just make it different limitation. For example, of this gauge, we can make the different color and font size. The color, well, for example, we can just this blue color. You see, we can check anything to make it more convenient for, especially for us. Now, how we can just combine and work with them. Again, let's press this button of the knob and right button of the mouse. We will ask to go to the right place in the program to add change callback of our push button. We ask this, and we go exactly to the right size of this of the program. Okay. Here we have the value. We can just write that the value of our knob, it is equal to application knob dot value. It's a real value dot sig. And now we need that this value will go. Okay, we already know it. Sorry. Now we need this application go to the gauge. We have here our gauge, and we just tell that this value of this gauge will be equal of our value from the knob. Okay, .NET. Let's run our example. It will ask us for the name of the file. Let's do its application number 1. Doesn't matter. We will just replace it. We'll get this here. Let's see if it worked. Now I can play with the knob, and you see changing the value of the knob. We can play with the gauge, and it will show different number. Okay, any question for this graphic presentation? Okay, let's
show me your code again, the callback function of the gauge.
Okay. Okay, here all this code is only 2 lines. First line, here our knob. It's what we insert here. We can see the equation. Its name we can get from here. You see this knob, it has the label, as you remember, and also knob itself. And knob value, we just tell that it could be any other. For example, it could be A. It could be variable, any variable A is equal to our value from the knob, from the input of our knob. And the output of input to the gauge will be the same value. I will go as an input to the gauge. We can just make it, for example, plus 10. Okay, let's now run this execution. And you see, I have here 5 plus 10, it's 15. Or we will go to 40, and it will 45, right? Is it clear?
Yes, thank you.
But when it's on 0, it doesn't show 10.
Sorry, when I put 0, it show 10, or just an increment, our difference.
Oh, sorry. It's just that when you just run it for the first time, it shows
Right.
0.
Yeah, you are right. We first should just to turn it, just to make it active, and then the way we can see the result.
Okay.
Michael, you could also set the initial value for the gauge, which if you want it to be 10, then when you open it, it's going to be 10, and then it's going to update. So it's
right here from
the open function, open callback.
Yeah, we can. We can just in the initial, we can just choose in this gauge. For example, here we can just we have limits from 0 to hundreds. We can just put from 10 to 10, and this way it also will work. Let's see. And you see it starts from 10, and also it will work. Okay. Let me show that not only numerical, we can just work with the logical numbers. Let's do another example. We don't need to save it. We just make another application designer, empty example. And we will check the logical we have. There is a no gauge. We can take the same gauge to see the result. Here the gauge, and we can take, for example, discrete knob. This discrete knob, as you can see here, it has only 4 4 positions: off, low, medium, and high. And also we can just to find a logical execution of this kind of problem. Let me show how we can do it. Let's go again to our callbacks. Again, we are in the right position, and here we have a value of our discrete. It should be here. We can take it from here, and it is a value. Okay, dot psi. But now this value is a logical. It's a string. It's not a number. We don't need it because it has it already. Okay, now what we can do, we can just make a comparison just to say if, for example, this is equal, okay, is equal, and to function our logical value, our string, and the second one from the discrete, it was off. And if it is off, we can ask our gauge go to 0. Application gauge value equals 0. The if, let me close this because I have no enough space. Now I will repeat it. Else if equal not off, the second was low. Let's take another value, for example, third of the scale, and the next if else if the third was medium. And let's do it twice more. And the last one we don't need just any else. It will be not off, it will be the last one high. If it is high, let's go to maximum. Let's check if we are, and we should, and yeah, and we have already, yeah. Okay, let's try to build it. Okay, now let's try to play from the low, and we have this in spite of our, now it's our knob, it's logical, it's discrete knob. We can work with the real numbers and play with our results. Okay, I think that it's clear. The last small example we will do, or maybe there are questions.
Could you please show the code again? I have a mistake.
Is catch and knob both handles?
No, I wrote exactly like you, but when I run it and I put it on low, it goes to 100.
And this line, have you checked this line? Value should be from the capitals. Each value, the final value from the variable should be capitals. Check, please.
I know. The problem was that I wrote the names with lowercase letters. Okay, thank you.
Yeah, okay, because Matlab is very important for Matlab or capitals, not capital, because it's just sensitive to the fonts, to the capitals. Okay. Now the last one example with the graphic. We already play with the live script. Let's play with the application designer, the same application designer. let's take the axis now. It's our graph. Our graph is just, it has also the variable in the component browser. It has a component application graphics axis. And here we can just, it was where this, it can be slider, okay? Now, this slider, we can maybe replace here. We will put amplitude for the beauty, amplitude, and the slider. Okay, we can just leave it as a slider, and in the slider we will go to the callback, right button, and we need a callback here. Okay, and in this slider, we will already have a value from the slider, and we need just to plot the graph. The graph, just we will plot it with the function plot of Matlab. We will use our value, first we should repeat the value from the argument from the axis. This way it works. This should be repeated. And now the function itself. The function itself is our value. I just copy it from here. Copy, it's our value. And we will multiply the value of the function peaks. Do you remember this function? We already played with this function. And here, or maybe not in the command window, we can do it in the axis. We can just limit in the ruler, we can make a limitation of the y plot. Let's make from 0, and maximum it could be 1000. Okay, the same way we can do it here, but let's do it in the component browser. That's all. Let's run our example. It also could be application, the same name. Okay, here we have the slider and the plot. Let me see if it works. You see, I play with the amplitude, and this way we can see different zooming. There is different presentation of our peaks plot. Again, it only works when we touch and we change the position of the slider. Only this way we can. I think that is quite impressive and interesting to work with this instrument application designer. Okay. Have you any question of this example? No. Okay, let me show you already. You can also play at home when you have time with the example that we put here in application design. The file open, if I'm not mistaken, R35. You already also, you should have it. Yeah, right. This is example of how we can build an application in Matlab to calculate the mortgage of payment for the apartment that we take as a mortgage from the bank. You see, it has a loan amount, which the total sum of this our apartment, and it is the year rate interest, how percentage will be paid each year, and for how many years we will take this apartment, and the result will be monthly payment. Let me show you in code view the function of this here this the example how to calculate it. It's just a standard classical formula for payment, for calculation, for estimation of the payment. In this way, we should just to insert it and estimate it in cycle. This example you have already in your files, and you can learn and play and repeat it if you have time. Okay, now let's run this application. We press the running, and we'll get it at standalone application. And we just, if we ask for 30 years, we will ask this, we will take this flat for 30 years. What is our monthly payment? When we press this push button, we have this graph. Oh no, it's too, let me. Here we can see the blue color, it's our principal returning the money that will be returned during this number of times, the number of months during 30 years. And this is our interest, how it will be go to the zero when we pay everything during the 30 years. Here we can play, for example, different number of months. For example, if I need to pay for 20 months. And you see my monthly payment will be much higher. It will be about $2,000 for each month. But if I succeed to take from the bank for 3% rate, I will pay less. Okay, and you are invited to learn how to work with this formula, because formula, again, let me show where it is this formula. When you open your code view here, you see we have two buttons, design view and code view, okay? And in our code view, you have all this line in the Matlab execution Matlab, and here there are our formula how to do it, how to work with this. Now, the last also complicated example, we have not only time, we have no even opportunity to build it because it's too complicated, but I'd like to show you because it's very impressive and interesting how it can be done using the toolbox, RSpace toolbox. Let's please write in the, we can write all again from the open file. We can open the file R3_6. If no, there is no. Let me again. Let's do it this way. We will open the application designer, and from there we can open this file. And from here we have application designer open R3. It should be here 6. Here it is. R3_6. And this example show the instruments in the cabin, in the flight cabin, and there are several instruments. There is altimeter, the speed, the vertical speed, the horizontal speed, and the artificial horizon, the torque coordinator, the compass here. And we'll using, not we will already took it as a ready application designer application, but this example, it creates an animation object and configure the object and set the number of frames per second. We can just see how it works. When I run this application, we will see not only the instrument from the panel, we also will see the object. The object will be the jet plane, not the jet, it's just a regular small plane. this plane, MATLAB also can use a body, an example made from the SolidWorks. This example is taken from the AC3D format from the SolidWorks, and also it can be rotated and can be shown from different kind of view. Now, when we start can we maybe put it here? And we can play in this application, changing the time of our here. When I change the slider with the time, we can see that all our instruments, they're starting to work, and also the plane also changed its position in the area, and all these bodies of the plane, there are from formats from the animation object from the aerospace toolbox. Okay, I believe that it's also interesting. Okay, now what time is it? Oh, well, it's 2 minutes, 7:30. Okay, I believe that you are tired. Maybe it's enough for our graphic user interface. Let me tell some words about our final project. Okay, let us close this example, and let's open a new live script. This was live script, not empty. We have already open our, where's our test? Let me find it. Okay. Oops, where is our MATLAB? Sorry, I should return our MATLAB. Okay, in our MATLAB, the file, let me see the file's name. Okay. Directory. It was a final, here it is, the final project. There is the name. Okay. Why we cannot open it? Okay, can you see the screen?
Yes.
Okay, what we are asking to do it, maybe it could be done for no more than half an hour, maybe who knows MATLAB, and maybe 2 hours for somebody who only just participated in our lectures number 1 and number 2. What we need, we have the equation, the first order differentiation equation here. And we ask you to solve this equation to find x as a function of t. Here we have 3 unknowns, and here we have the time also and the initial value. We ask you to prepare this solution of this equation. You can do it in MATLAB, you can do it in Simulink, you can do it in LiveScript, you can do it also in Application Designer. But please choose this parameter, this factor A, let's take it from your last digit from your phone number. And B, please take the last but one digit in your phone number, and the C is the last but two digits in your phone number. I took nobody from your list has no 30 at the as the last digit in your phone number. This is way any number should be not zero. And we are waiting. Please send to my electronic address that you already have the result. This script, it should be small, short script. It takes no more than maximum 2 hours. Just the solution of this equation. It could be done again. You can do it in any kind of Matlab, Simulink, LiveScript, or application designer. And please send. I believe that the last session that we will get in a week, Tuesday evening, we can just discuss the solution, we can see the results, and those who will send it will get this certificate about the finishing the course. I don't know, maybe we can do it more than a week. Professor Katz, can you explain, can we wait more than a week maybe for getting back the solution of this final project? Do you know the time? How can we wait till it expires?
I really don't mind. The goal is that they will do something. So if they will do whatever they will do, if you don't show them the solution, they can submit it. But I don't believe that if the people will not do it in a week, they will not do it, period.
Yeah, I believe, because it's
so
very
I think that a week is a fair time. And if you want to do it within this week, then it's fine. If you don't want to do it, don't do it. It is also fine. It's for you to do something and feel that you know something about Matlab. This is not something that, you know, I don't think it's an issue. I think, Yuval, what do you think? A week is fair time?
I think a week is fair, yes.
Okay, that's it. So he is the boss, and that's it.
Okay, okay. And now let me finish this presentation, and we will wait for your project. Please send it to the address, and let's meet next week. Next week, next Tuesday, and we will discuss the results of our exercises. Okay. No.
Okay, thank you.
Yeah.
Thank you very much.
Yeah, thank you.